Okay, as the first algorithm, I'm going to show you how round robin scheduling algorithm works. And for this example, I'm considering time quantum as 2. And in this table, you can see the set of processes that I will be explaining in this example, and their arrival times and their burst times. In the request lineup section, I will show you how each these process will be queued, and in the process queue you can see the timeline how these processes will be executed. I have marked time 0 here, and yep. Okay, let's get started. Okay, first consider process P1. It arrives to the process on time 0, has a burst time of 4, which means that this one needs additional time quantum to complete, which is 2 time units. So I'm gonna mark the remaining time here, and I'll mark P1 as executed. All the executed process I will mark in red here, so it's easy to figure them out. And P1 will execute on the timeline like this, since this will be 2 because the time quantum is 2, right? By the time 2 processes P2 have and P3 has come to the processor, so I have to add P2 and P3 to the queue, and P1 also has a bit of time left, since one time quantum left, because its original burst time was 4, right? This will be the queue, and P2 is next in the queue. If I type P2, it has a burst time of 5, which means that this one needs additional 3 time units to complete. So P2 will add 3 timeline like this, and P2 will be executed, right? By the time 4, we already have P4 in the came to the processor, so I have to add P4 to the queue, and P2 still has need another 3 time units, so I have to add it to the queue. Like, next consider P3. He's the next in the queue, and if I take P3, it has a burst time of 6, which means this needs an additional 4 time units, 2 time quantums, and P3 will be executed. I'll add P3 into the timeline, and time will be 6, and by the time 6 we have P5 already come to the processor, so I have to add P5 to the queue, and P3 need to be queued, since it needs some additional time. Next, it's P1 who is in the queue. If I take P1, it only needs another 1 time quantum, so it doesn't need any additional time, and P1 will be executed. Timeline will be 8. P1 will be executed. It doesn't need any time, so it doesn't need to be queued. By the time 8, we have P6 come to the processor, so I have to add P6 into the queue. Next is P4 who is in the queue. P4 needs only 1. Did I mark P1? Let's see. P3 needs 4. And 2 time units. P3 needs P1 again. P1 needs 2. Right. Next, I have to consider P4. P4 is the one who is next in the queue. P4 only needs 1 time unit. It only has one burst time of 1, which means it only needs it will be finished on the first run, so I will mark it as 0, and P4 will be finished. By this time, all the processors have come to the processor, so there are no new processors, and P4 doesn't need to be queued, and I'll mark P4 here like this, and the timeline will be 9 this time, because this only had a burst time of 1. Right. Next, I have to consider P2. P2 has a burst time, needs another 3 time units, so it needs another additional 1 time unit to complete, and so I have to add P2 into the queue, and I'll mark P2 here. So the timeline will be 11. Right. Next, it's P2. Sorry, I have to mark P2 because P2 already executed. Right. Next, it's P5 again. So P5 has a burst time of 3, which means this needs another additional 1 time quantum unit, and P5 executed. I'll mark P5 here, and the timeline will be 30. And again it needs to be queued, so I'll add P5 to the queue. P3 needs another additional 2 time units. It needs to be queued, and I have to mark this P3 as executed, and P3 will run till 15. Right. Next, it's P6. It has a burst time of 2, which means 1 time quantum. It will be finished on the first run, so it doesn't need to be queued. I mark it in red. This doesn't need any additional time, and P6, I'll add P6 to the timeline. Right, next it's P2 again, and P2 only needs 1 time unit. It doesn't need additional time. I'll mark P2 as executed, and it doesn't need to be queued again because it finished, and I'll mark P2 in the timeline like this. It will be 18 because it only needed 1 time unit. P5 again, and P5 again only needs 1 time unit, so it doesn't need the additional time. I'll mark P5 here, and the timeline will be 19, and P5 will be finished. And finally it's P3, and P3 needs 1 time quantum, 2 time units, so it will be finished on this run. It doesn't need to be queued again, so I'll mark this one as 0, and mark P3 as executed, and add P3 to the timeline. So hope this explained how round robin schedule algorithm worked. And next I'm going to explain you how shortest job first algorithm works.